Hello my friend, happy to see you here, welcome back to my channel. Today we have great and relaxing algebra question. We know that the sum a plus b equal to 12 and a product a times b equal to 18. We need to solve this question for a and b, so if you want to test your intuition, if you want to test your algebra skills, write your solution in the comments below. It will be really interesting to read about your solutions. And right now let's start. First of all, we have system of two equations. What is the main method? How can we solve this type of question? Of course, from first equation, let's express our a or b. In my case, for example, let's express our b from the first equation. So we have b equal to 12 minus a. 12 minus a. And right now, let's plug in, instead of this b in the second equation, let's plug in 12 minus a. So let's plug in this expression instead of this b. Let's do it. So we have a times 12 minus a, and equal to 18. And right now, if you look closely, we have only one variable. So it looks like this is a quadratic equation. So right now, let's simplify the things and let's solve it. So first of all, let's multiply our a by this parenthesis. So we have 12a minus a squared and equal to 18. And right now, yeah, this is a quadratic equation, but we prefer a little bit different order. Yeah, we prefer square on the first position, a on the second, and this coefficient c on the third. So that's why let's change this order. First of all, minus a square on the first position, then I think plus 12a, and from the left side minus 18, okay, minus 18 and equal to 0. And left and tricky moment, we're gonna multiply both sides by minus 1. And a lot of students might be asking why we do this, because right here we have negative sign. So let's everyone prefers a classic order of signs without a negative sign right here. So everyone prefer a square, x square, b square. Yeah, so that's why we need to eliminate this negative sign from here, and the best method is to multiply both sides by minus 1, and of course we will change all the signs to the opposite one. This is not a mistake, this is a great trick. So a square right here, negative, so minus 12a and plus 18 equal to 0. So I really hope you understand my solution until this moment. This is our first step to get closer to this quadratic equation. And what we're going to do next, of course, we need to solve this quadratic equation, and this is up to you. I'm going to use the basic and the classic method of coefficients. So that's why I'm going to write it right here, our coefficients. So a equal to 1, b equal to minus 12, and c equal to 18. And right now, let's plug in these coefficients into this spot. But first of all, every time I have these quadratic equations, I prefer solving this question for discriminant real quick. Yeah, so let's do it. So discriminant equal to b squared minus 4ac. As a result, what do we have? B squared, so minus 12 square minus 4 times a times 1 and times c times 18. So let's simplify this. So minus 12 square equal to 144, minus 4 times 18 equal to 72. So as a result, our discriminant equal to 72. Our discriminant is greater than 0, yeah? So right here we have two roots, two real number roots. This is also really great. So right now let's plug in everything into this spot. So we have a first and a second equal to minus b plus minus square root of discriminant and all over to a. Right now let's plug in everything into this spot. So minus b minus 12 plus minus square root of discriminant square root of 72 and all over 2 times a, 2 times 1. Okay, right now let's simplify this. First of all, right here, we can cancel these negative signs. Not like cancel, but negative times negative equal to positive. This is a kid's rule, yeah? So we have 12 plus minus. And right now, square root of 72. How can we express this 72 by a product? Because square root of 72, this is not a table case, yeah? But the main thing, if you have problems with it, my quick recommendation is to write this 72 on the right side of your paper and divide it 72 by 2 or by 3 step by step. So that's why if we divide this 72 by 2, we have 36, and 36, this is a great constant for us. We can easily divide it by 36 and 1 and 1. So as a result, we can express this 72 by 2 times 36. And why don't we divide the 36 by 2 and by 2 once more? Because 36, square root of 36 equal to 6. So that's why we don't need to divide this more. So 2 times 36. So 72 equal to 2 times 36. All over 2. And a lot of students might be asking why this expression, and my quick trick right here, because 12 plus minus square root of 2 times 36, so square root of a product equal to product of square roots. So we have square root of 36, I'm going to write it on the first position, times square root of 2, and all over 2. And the final step, 12 plus minus square root of 36 equal to 6. So we have 6 square root of 2 all over 2. And the final tricky move, we need to divide our numerator by 2. We can easily do that. Of course, there are two methods. Maybe the easiest one I'm going to show you is to factor 2 from our numerator, equal to 6 plus minus 3 square root of 2. Plus minus 3 square root of 2 and all over 2. This may be the most understandable method. We're going to cancel these two, and as a result we have 6 plus minus 3 square root of 2. But the second one, you can also do it in your head. You can divide this coefficient by 2 and this coefficient by 2. So 12 divided by 2 equal to 6. 6 divided by 2 equal to 3. Of course, this is maybe the clear method for your teacher, that you factor it. And this maybe, if you don't have a time, you can also do it in your head. So this is our answer. Let's write it right here. So our a first and a second. So a first, let's write it with the positive sign, doesn't matter. So 6 plus 3 square root of 2, this is our first root. And the second one, a second, equal to 6 minus 3 square root of 2. But one really important moment, this is not a pair of roots, because in the beginning we had that our b equal to 12 minus a. So that's why we need to write that our b first equal, so our answer is pair a first b first, not a first a second. So we need to solve it for b as well. So b first equal to 12 minus a first. So that's why b first equal to 12 minus a first, this one. So 6 plus 3 square root of 2. Of course, don't forget about parentheses. This is extremely important part. So we have b first equal to 12 minus 6 and minus 3 square root of 2. 12 minus 6 equal to 6. So our b first equal to 6 minus 3 square root of 2. Okay, and right now let's solve it for b second. But one really important moment right here, we have absolutely the same principle, absolutely the same algorithm. So that's why b second equal to 6 plus 3 square root of 2. So our roots are absolutely symmetrical, okay? So we have our first pair with the plus sign, plus minus, and second pair minus plus. Of course, if you don't trust me, you can easily check it, but we will have absolutely the same thing. In parentheses, we have negative. With when we multiply it by positive, by negative, we have a positive. So that's why we have minus plus right here, plus minus. So let's write our final answer to this question, and in the end, let's check our roots. So our first root equal to a first, b first, so 6 plus 3 square root of 2, and 6 minus 3 square root of 2. And second pair, 6 minus 3 square root of 2, and 6 plus 3 square root of 2. And we can write that this is our answer. This is our answer to this question. And right now, in the end, let's check real quick our roots. First of all, I'm going to write our system of equations right here. So a plus b equal to 12. And AB equal to 18. Right now, let's check real quick. And one really interesting moment, because right here we have addition and multiplication. A plus B is the same sorry, as b plus a. So that's why we don't need to check both of these pairs, because we have absolutely symmetrical roots. And doesn't matter. We add right here this root to this root, or this one to this one. We have absolutely the same thing, because a plus b equal to b plus a. So that's why let's use, for example, the first root. So 6 plus 3 square root of 2 plus 6 minus 3 square root of 2. We're going to cancel this one. As a result, 6 plus 6 equal to 12. So our addition is great. So a plus b equal to 12 is absolutely great. And in the end, let's check real quick our multiplication with the same principle. A times b equal to b times a, so we don't need to check both of these roots. We're gonna check, for example, this one and this first. So as a result, we have 6 plus 3 square root of 2 and times 6 minus 3 square root of 2. A lot of students might be thinking, okay, let's multiply parentheses by parentheses, but this is a classic formula. I hope you remember from school, a minus b, a plus b. And what do we have on the left side? This is a difference of squares. So x squared minus y squared equal to x plus y, x minus y. Yes, so we have x plus y times x minus y. What do we have on the left side? This is a difference of squares, x squared minus y squared. So we can consider this expression as difference of squares. 6 squared, let's write it. So this is a 6 squared minus 3 square root of 2 square. And right now, 6 square equal to 36 minus 3 square root of 2 to the power 2. We need to raise this 3 to the power 2 and square root of 2 to the power 2. 9 times 2, because square root of 2 to the power 2, we're going to cancel it. So we have 9 minus 9 times 2 equal to 18. 36 minus 18 equal to 18. I hope you see it right here. Oh, I write it right here on the right side. So 18. As a result, a times b equal to 18. So absolutely the same expression. So our roots are great. Our roots are absolutely correct. You can see this proof. This is a quick proof. Quick check right here, because a lot of students don't like to do this proof, don't like to check their roots, and sometimes they end up with the wrong solution. So that's why every time you have this type of numerical expression, system of equations, just spend like 1 minute to check this root real quick. It's also really great for you and for your teacher to see this from a different angle, that your roots are absolutely correct. And of course, it's great for you. You will be proud of yourself. You will be absolutely happy that you solved this question correctly. So this is my solution to this question. I really hope you understand it. I really hope you learned something new. Definitely don't feel bad if you got this wrong. And yeah, thank you for your time. Have a great day. See you in the next videos.